Here we have some nice kind of stagecoach. There are some LEDs on it. Along the car, there's this one, there's a LED in it. And the horses should move their heads if it's running, it is connected to the mains. But it's totally dead, so we will analyze what's the problem. I analyzed the power switch. It's a 3-level switch. In the middle is off, on the left is music, and on the right it's on. I measured the switch in the middle, that's the black wire. On one side it connects the black wire to the green and or the white, I don't know which one, but on the other side it connects to both the green and the white line on the switch. This is the interface, very small one. It has 2 resistors on the back side, probably as a series resistor for the LEDs. There is some engine that makes the movement of the horses. There's a little microcontroller on it, and the wires are going to the LEDs. But I first have to analyze which wire goes to where. I'm going to cut all wires and measure them one by one. But first I see 2 yellow wires. These are connected to the middle. So it doesn't matter which one is which one. But the white wires, there is one from the center and there is one behind the resistor. So that one from the center, I colored it black and I cut it in 2, so I know the black and the black wires are the same. Also this tiny black wire, one side it has a knot in it, and that knot is the same wire as the yellow wires. As long as I know this and remember this, I can experiment and cut the wires. I forgot to tell, if I measured the resistance between the plus and the minus, it was a shortcut. It was 1.0 ohms. This one of these items is causing a problem. Not this one, I disconnected and measured, it's still 1 ohm resistance. The thing I did, I soldered some pins to the power supplies. It's not very nice to see, but it will work. I marked the wires with some tie wraps and I will cut them between the tie wraps. I connect the multimeter to the black wires. In a diode situation, the LEDs lights on. You can see the LEDs on the car lit up, and you can see the red is the plus, so the knot in the black wire is the minus. But this string is not a problem because the LEDs are just lighting up. And I measure the white yellow leads, 2.4 ohms. Also if I switch the connectors. So this is the faulty, at least this is one of the faulty parts. I'm not sure, but I think you can see the wires going in. It's an engine to turn the wheels, I think. But the whole apparatus, it is all is glued. There's no screw behind. All is glued. From the back side, there is also no screw to see. I think this engine inside will also drive the wheels, but probably also turn the leads to make the horses move. I think the upper part is glued onto the chassis, and there are 2 screws per wheel, and I put them in box 18. First I remove the wheels. You can just pull them off, and then I tried with a knife and a hammer. I tried to move away the glue here, but then I used this saw, and now I'll try to open it. I also tried this saw, iron saw. And finally I succeeded to open the case, and there's a a motor in it with some gear. I damaged my finger. I had to cut out a piece, otherwise it wouldn't recognize my fingerprint with the camera I make these pictures with. But anyway, we'll investigate the motor. I think the motor has shortened, but we will find out. There's two things here. I measured the resistance of the motor, but the yellow wire has come loose. It was loose, I don't know. But still it measures 2.1 ohm. So I think this engine, I think it is defective. I'm not sure. I will first solder the yellow wire and then put some power on it to see if it's going to move. The engine, if I feed it with 3 volts and set the amp limit on 1.6, it uses 1.6 amps. So I asked ChatGPT, what is the average of a DC motor resistance? 1 to 5 ohm. So it could be that the engine is not defective, but maybe it is stuck. But then I'll have to remove all the side screws. Then we will try out that. I will unscrew these 3 first, and I put them in 20. After removing both sides, 6 screws, I will now unscrew these 7 screws and I'll put them in 21. But before that, I will unscrew these 4 to remove the whole system from the frame, and I put them in 9. I managed to remove the 2 screws that hold the motor, and I put them in 10. I then remove this one by pulling it off. And we put it in 11. I removed the tire wraps from the yellow-white wires, and this is what you see if you open the engine. Some gears must be on the left, some must be on the right. I re-soldered the wires because they were very bad. They hardly made contact. I connected to the multimeter in the ohms situation, and if I turn the wheel, you can see otherwise one side and the other side it reacts. So it's not, I don't know what it means. I then connected the motor to a micro amp meter, and if I turn the motor, one side it goes positive, other side it goes negative, about 25 microamps. So it seems as if the motor is not defective. I finally just turned up the voltage to 4 volts, and suddenly it starts turning. I now reduced it to 0.4 volts. It draws about 15 milliamp, and you can see it's turning. At 4 volt, it draws 28 milliamps. So I don't know what happened, but it works again. I then reconnected the motor to my ohm meter, and now it measures 11 ohm. Well, I was trying to ask ChatGPT. First I wrote down the question in English and let it speak out.
A small DC 6V motor from some toy for children. It measures a resistance of 0.4 ohm and it does not turn, and I do not feel any mechanical resistance when manually turning the axis when applying 2V DC. It draws at least 500 milliamperes as the power supply used was set to a limited of 500 milliamperes. I then turned up the voltage to 4V and suddenly it starts turning. Now, even at 0.4 V it turns, drawing 15 milliamperes. I remeasured the motor resistance, and it now is 11 ohm. What was happening here?
This question I asked to ChatGPT, and I asked ChatGPT to speak out the answer. It's here, I will show you when speaking.
What you experienced is likely due to oxidation or a temporary short in the brushes or commutator, which was burned through or cleared when you increased the voltage. Step-by-step breakdown of what likely happened. 1. Initial high resistance, 0.4 ohm. The resistance you measured initially, 0.4 ohms, was unusually low, suggesting a possible internal short, e.g. carbon dust, metal debris, or moisture bridging the brushes and commutator. Alternatively, poor contact between the brushes and commutator due to oxidation or dirt could have led to a high initial current draw with no movement. 2. Motor not turning at 2 volts. The motor likely didn't turn at 2 volts because of high resistance at the brushes or commutator. The 500 milliamps current limit prevented the motor from getting enough current to punch through the issue. 3. Applying 4 volts, motor suddenly starts moving. When you raise the voltage to 4 volts, a higher current likely burned through oxidation or debris, restoring proper electrical contact. This is a common phenomenon in brushed DC motors that have been sitting unused or have poor brush contact. 4. Motor now runs even at 0.4 volts, 15 milliamps draw. Once the oxidation or dirt was cleared, the electrical path became low resistance and clean, allowing the motor to work normally. The 15 milliamp draw at 0.4 volts indicates that the motor is now operating efficiently with normal brush contact. 5. Remeasured resistance is now 11 ohms. After the oxidation or contamination was cleared, the true winding resistance of the motor, likely around 11 ohms, became measurable. The initial 0.4 ohms reading was probably an artifact of a partial short or bad contact, rather than the actual coil resistance. Conclusion. Your motor was likely suffering from dirty or oxidized brushes, or a minor internal short. Increasing the voltage and forcing it to spin cleared the issue, restoring normal operation. This is a common fix for small brushed motors that have not been used for a while.
So I think the conclusion must be that the power supply, the original one, cannot supply enough current to let the motor go to some point where it is stuck. Using the external power supply, it can deliver much more current and it can make the motor go through that point where it is blocked. So if a toy with a motor has been stored for a long time, oxidation can occur and you just don't use the original power supply, just use a power supply that can supply an enormous current and connect it to the motor, and probably it will then start running. So I replaced the motor, and this one has to be clicked onto this one, turn it right up. I was wondering what gear was driving the wheels. Well, this is the final one. That will touch this gear, and this will make, with a differential, it will make the wheels turn. I reconnected both parts with these 7 screws, and I think you should not turn it too fast, because these hold-offs, they are, in my opinion, 3D printed cylinders, and they can't, just don't screw it too fast, or otherwise it will get loose. Now the proof of the pudding is in the eating. I connected the motor to the external power supply. I set it to 4 volts, 500 milliamps, and let's go. And look, it's turning. And I think it's all working very well. Well, as usually with repairing, I forgot something. I forgot to mount the engine bracket. So I have to reopen it and put a bracket on it. Trying to move or to fasten the horse range, as it is called, I think. But you have no room, so I hang up the housing cage to my lamp. So I started to solder it all together using shrimp. I don't know what the English word is, but these kinds of things to cover the solderings on the wire. Reconnected the original power supply. When I started, some movement is there, but this light where I soldered does not light up. Stop. Look, you can just put it out. This kind of connector you put in. So we will measure this lamp first. With the multimeter in the diode position, you can see the LED is lighting up. So this light is okay. The outer connection is the minus and the inner connection is the plus. This lamp is removed. I start to the right. No voltage is shown in the middle. Then I started to the left. Music is playing. This little microcontroller is controlling this speaker, but still no power on this line. We will find out. Red wire wasn't correctly connected, so if I now start it, you can see it's 4.5 volts on this, but the LED doesn't light up. Set the multimeter in the resistance position. I connect the minus to one pole and I measure inside. It should be the outer side. It measures continuity. Then I connected the multimeter one side to the other wire. This is the other pole. And go inside and make contact with the central pole of this connector. There's 82 ohms. It's a little bit strange. When I punch the probe in the wire, there's 1.3 ohm. So if we measure if there's continuity between the plus and the inner pole, whatever you call it, of the connector, I will try to contact it very close, very good. So I'm pressing now, I contact it. There is no connection. So there is a discontinuity somewhere between the positive voltage and the positive pin inside here. Well, I fumbled a little bit with the wires and look what happens. There's no connection. It's broken. Now we're going to try to fix it. So I tried to open the socket, the screwdriver, removing all kinds of glue with a knife. Finally, I succeeded prying it out. I soldered the wire and let's start it. Look, it's lighting up. So finally it all works. On this side the lamps are on. On the other side it's playing music. The horses are running. And I will make it a little bit more to restore something. The horse heads are a little bit bowed. They are mounted on a spring on the body. and turned or by the wires, but we will see. I also made a little announcement. All my projects, I start with HVW, my name Henk van Winkoop, is the year, the month, day and the time, 1302. My name, Repair Café Dalfsen, is in the Netherlands. This is my phone number. In Dutch, problem, the motor was stuck and there was a loose contact to the lamp, lantern, I don't know what you call it in English, but I always put a little note inside, so maybe future repairman will know what has happened. The underside, there was no cover delivered with it. According to me, it's kind of gypsy, I don't know how you call it in English. So I found some transparent plate I removed from some laptop or whatever, and I draw the circumstances and I will cut it out and see what it does. Finally, I don't want to spend much time on this cheap toy. The bottom part was missing, so I made one very simple by using knife and break off. So it's not very nice, but I think it's functional. And I will glue it with these, and that will be enough. Finally, I was finished and I thought all is well. Then I started it up, and then I see that two LEDs, these two are not lighting up. Well, we're going to investigate that. If I measure between those 2 points, between the last LED, the third one from the end, which is still burning, lighting up, and the second from the end, there is 1 ohm resistance between them, so they are connected, but the other 2 wires, the other wire is not connected. Probing the other wire until the one but last LED with my left black probe, resistance, there's continuity, they are connected, but the LED does not light up. So I think something in the LED itself, or the LED holder, there is some disconnection. Switch it on and look, sometimes it doesn't. There's some discontinuity in the lead to this one but last LED. I found out that these are just LEDs you can stuck into these sockets. Place them into the socket, and if they made not good contact, then they will not light up. So we leave it as it is. It all works now. So finally, don't look at the mess. It works, all works fine, the horses are running, the wheels are turning, the LEDs are lightning. This lantern, or whatever you call it, is also running. If you switch it off and put it on the other side, it does the same, but it plays some music. Well, let's switch it off. It was a pleasure to try to repair this thing. Thanks to the Repair Café in Dalfsen in the Netherlands. Thank you for viewing.